Hi, my name is Brian Caffo, and this is the lecture on the perfect data science experience versus real life. Let's start by talking about the perfect data science experiment. Here we've got the happy little cat looking at a highly significant p-value. So in the perfect data science experiment, you have clearly defined hypotheses that are specified a priori. And experimental design is available to you. For example, you can use randomization across the treatment of interest. You can stratify or block on some nuisance variables. Your sample is a random sample from a population of interest, so you know that it's generalizable. And the data that you have are directly able to interrogate the hypothesis that you're interested in. All the data set creation and merging and data pulls from the larger data set goes smoothly. There's no missing data or dropout. And your analysis is robust without the need for any sort of advanced modeling. Your conclusions are clear, and parsimonious knowledge is gained via the experiment. And the decision is obvious being given the data and communicated clearly with a nice report or outgoing data product. What happens in real life? Well, in real life, often the data is needed to both inform the hypothesis and interrogate the hypothesis. Often multiple comparisons are an issue because you've tried several different hypotheses or you're looking at multiple things at once. Often your access to experimental design is limited or non-existent. The data is often completely observational. So the population being studied isn't the population that you're interested in. That's often a problem. Your sample isn't representative of the sample you'd like to generalize to. The data don't have the exact measurements that you need to evaluate the hypothesis. This is a surprisingly common problem. You'd like to study caloric intake, but all you have is questionnaires asking people how many calories they ate last week, which they can't usually remember well. The data set is problematic. Merging is problematic with multiple matches or no matches. Data entry errors. The data pull doesn't go the way that you want. So often the case that just the reality of building the analytic data set is a challenging process. You have missing data, and because of the observational nature of your experiment, advanced modeling winds up being required. And then because you need advanced modeling, advanced computing is needed to fit the model, which raises issues with robustness and bugs. Then you're all done with this process, and the conclusions wind up being indeterminate. And the decision is not substantially further informed by the data and the models that you fit. So that's what happens maybe in some of the worst case scenarios, but that's more like what tends to happen in real life. So in this class, we're going to contrast data science in the ideal versus data science in real life. We're going to talk about different variations of experimental design versus observational studies. We'll talk about some ideas for how you can check for errant data and other tools to make data analysis in real life a little bit more manageable. So the class is set up as this introductory set of lectures plus then 6 lessons. Each lesson has a quiz. Each quiz has 5 questions. You need to pass 4 out of the 5 questions to get credit for the quiz, and you can do retakes. Before each lesson, or at the beginning of each lesson, is a reading, and I would suggest you do the reading before you go on to do a lot of the other materials. So I'm going to finish this lecture in a second by giving you some examples of data science in the ideal versus data science in real life that I've concocted. But welcome to the class. I'm really glad that you're in it, and I look forward to working with you for the next couple of days as we talk about data science in real life.